States of matter and space phenomena.
First, let's talk about the states of matter: solids, liquids, gases, and plasma. These forms are present throughout much of our world and outer space. Solids. Atoms are packed tightly, which restricts their motion. Solids have a definite volume and shape. Examples include planets, comets, and stars. Liquids. Atoms are loose or in constant random motion. Liquids have a definite volume but not shape. Water is a type of liquid. Finding water on other planets could mean that there are alien life forms there. Gases. Atoms are scattered and don't have a definite volume or shape. Plasma. Free electrons are floating around, forming a hot ionized gas. 99% of the universe is plasma, and it appears as lightning or solar winds.
We can find these states of matter in many space phenomena, of which include stars, made of plasma and gas. They're classified based on temperature and the elements they absorb. There are 7 types of stars: O, B, A, F, G, K, and M. Most of these stars absorb ionized helium and hydrogen, gases, but some stars, such as type G, absorb neutral or ionized metals, such as calcium. There are 5 main properties of stars. Luminosity, how much energy the star generates and then releases as light. Less energy means less light. Brightness, how we perceive a star's light. Radius, the size of the star. Chemical composition, what elements the star is mainly composed of. Temperature, how hot or cool the star is.
The mass of the star plays a huge role in its life. A star is born inside of a nebula, which is a cloud of gas and other matter. It's also called a stellar nursery. The center of the nebula starts to spin and heat up, creating what's called a protostar. If the star is average, like our sun, it will end up becoming a red giant, then a planetary nebula, and finally, after all the energy is released and all the matter is cooled, a white dwarf. If the star has more mass, it will end up becoming a red supergiant, then a supernova, and finally either a neutron star or a black hole, where a ton of mass is concentrated on one single point.
You may ask, well, does matter in space ever run out? To answer that, let's look at a process called galactic recycling, also known as the star-gas-star cycle. This is when matter, such as elements and gases, are released from stars as they die. This way, new stars or other objects in space are formed from the material of dead stars. However, many galaxies like our own Milky Way don't have enough raw material to keep up this recycling process for more than a couple billion years. Surrounding the galaxy is a cloud of gas known as the circumgalactic medium, CGM, the galaxy's star-forming field. Matter is constantly recycled in the CGM. There are also galactic outflows, fountains that push matter out of the CGM and into the ISM, interstellar or intergalactic medium, which is the area outside of the CGM that fills the space between galaxies.
The universe is a pretty big place, which is why we need people to explore it. Astrobiology is a possible career field here. It is the search for human habitable places in the universe and evidence for alien life. The education required is a PhD in biology, chemistry, physics, geology, or astronomy. A typical working day for an astrobiologist can include studying pictures from deep space satellites, creating computer models of stars, moons, and other planets, studying moons and planets, analyzing fossils to learn how the earliest life forms began on Earth, studying bacteria that can survive in harsh conditions, and writing grants for funding, which is also really important.
To summarize, the states of matter act as foundational building blocks in all topics, especially space exploration. Matter appears in our daily lives and all around the universe. In this presentation, we've covered star properties, a star's life and death, as well as the recycling of matter in galaxies. We've also introduced a career path, astrobiology, that aims to discover life on faraway planets. All in all, the universe is full of incredible and extraordinary phenomena. There's always a lot more to discover in this universe, so keep exploring!